divide by 1000. Okay, so maybe let me just write down the working. Okay, are we clear about that? Alright, so in this case, if I were to simplify this one, okay, I will want to multiply by what? I multiply by 50 across the entire thing. Sorry? Oh, 6. Okay, I multiply by 50 across the entire equation to get rid of the denominator. But if you want to multiply by 1000 also, okay? Then after that, yep. Why I divide by 1000? Because the question gives me the rate of change to be 320 meter cube per hour. But over here just now we understood that the rate of change negative 1.04, it is for 1000 meter cube per hour. My V value is 1000 meter cube. So actually over here I times 1000. But this value over here did not account for the 1000. So that's why, did not account for the 1000. Alright, it is after accounting for 1000. Okay. After accounting 1000, so I need to divide by 1000 in order to fulfill the meaning for V in this equation. Yes,
This is why is really 1000.
this is after 1000. This is after times 1000. Yeah. Okay.
What's the question?
Anybody to understand still? Okay, then after that we solve this equation. Okay, so the time when the water volume is decreasing at a rate of 320 meter cube per hour, that will be when t equals to 0 or t equals to 8. Why do I? Why did I reject t equals to 0?
That's you calculate. This is the initial.
But that's the initial volume.
And then it cannot decrease.
At the start can already decrease. T equals to negative 8 over 25. 0.3 times 1000. Can what? Okay. Can I go and find out again why t equals to 0 is to be rejected? Sorry, it's in my mind. I don't know why I wrote rejected here.
Textbook also says rejected. Yeah, it only says it.
Sorry, why? They give the answer 8 only, right?
Yeah.
Yeah. No, that's the volume. But if t equals to 0, my dv over dt is negative 8 over 25 times 1000, it is 320 what? Negative 320. Huh? Any guesses?
Oh, is it like because right when t equals to 0 right, the hydro-powered device like never turned on yet, so they assume that nothing happened yet.
This is the best question. It's not an essay for you to describe. Okay, I'll go think about it. Why? Because at the start when during a 12-hour period the volume of water right at the beginning it can already be decreasing what?
Like equal to 0 is still max. Still max, right? And equal to 0, there's no drop.
There's no drop lah.
Yeah, it's
Okay
still
lor.
max.
Okay, I think of that answer as well. Okay. Because so we reject t equals to 0 because it just started. No lah, for everyone to understand why we are rejecting one, right? Okay, just tell you, okay, reject, then you accept it, cannot, right? Must tell you why, right? But I'll go and think about it.
Will this kind of come out in exam?
Huh? Oh, when it comes to differentiation, a lot of things happen.
No, but like this, where we don't know whether to reject.
It will be clear lah. Okay, exams wise, it will always be very clear. Okay, of course I cannot promise you that school-based exams will be clear because we only vet for like 1 month. Okay, whereas SEAB exams, I'm sure they vet for 1 year. Okay, so I'm sure it has already been set to the exam. Okay, so let me erase this, yeah. Okay, let's look at another question. Let's look at exercise 15.3. Question 3. Okay, so we are looking at the radius of a body changes with time t seconds. Okay, body meaning an object, not the physical body. Okay, with time t seconds, and they are related by the equation r equals to t squared plus 2. Okay, so this is in cm, and this is in seconds. Okay, we want to find out what is the r over dt and calculate the rate of change of r with respect to t and t equals to 2. Okay, so differentiating this should be simple by now, hopefully. Okay, so the r over dt is equal to 2t, and then at t equals to 2, the r over dt is equals to 4. Okay, I do not recommend you to actually leave your answer like that. Okay, when it comes to applications of differentiation, okay, always write statements so that you don't get shortchanged for ambiguity. Rate of change. So the rate of change is 4 cm per second. Okay, so part 2 we want to sketch the graph of r equals to t squared plus 2 and then explain the changes in r with respect to t. Okay, so taking the context into account, t, can it be negative? No, right? Okay, so your graph must be able to show that as well. Okay, so r equals t squared plus 2 is a quadratic graph. Okay, so it is actually like that. Okay, if you're looking at positive values of t only. Okay, so in order to explain the changes in r with respect to t, okay, so we will say that the radius of a body increases as time increases. Okay, because we want to explain the changes in r. So how the radius of a body increases, that's the change. As with respect to t, that means as time increases. Yep.
Radius means what?
What do you mean radius means what?
Radius.
See, that's the context, that's the question. The question in this, the beginning says the radius of a body changes with time t seconds. Body meaning an object, not the physical body. Okay, last one for the day. Okay, the stopping distance skm of a van moving at v kilometers per hour can be modeled by this formula. So this is in km and this is in kilometer per hour. Okay, so you find that actually the questions in this particular unit is very routine. Okay, so it's just simple differentiation. Okay, such that it's 1 over 8 plus 2v over 80. And then when, sorry, what am I writing here? When v equals to 60. So ds over dv is equals to 1.625. Okay, so likewise, and answer the question clearly. So ds over dv is just a rate of change. Okay, so we just keep to that. Phrasing will be fine. Change is 1.625. What's the kilometer?
So it's just 1 over hour.
No, it is 1.625 hours, right? Because the units in this case for ds over dv, okay, I'm just writing in a loose notations, okay, so you cannot write it in this way. So s is actually in km, right? Then divide by kilometer per hour, right? Correct? ds over dv, this is s, this is v's unit. Okay, so that means kilometer divided by kilometer per hour. So kilometer times hour over kilometer, cancel equals to hour. Right? You know this is how your notations work, right? Your units work. Physics got teach you, right?
Teacher is still rate of change. It's just hour.
Okay, maybe let me rate of change of
Time taken.
change of stopping distance per unit speed. Because actually in part 2 they ask you to explain the meaning of your answer, right? Okay, tell you what. Okay, because actually this question they actually asked to calculate ds over dv. Okay, so we calculate the value, we just put in the units over here. Okay, because actually in part 2 they ask you to explain the meaning. Okay, so explaining the meaning itself, okay, because we know that this means that it is the change of the distance over the change in speed, right? Okay, so this will mean that it is taking 1.625 hour for a van traveling at 60 kilometers per hour to come to a stop. Yes, because in this question, talking about stopping distance of a van moving at v kilometers per hour. Okay. So we do not know what is the stopping distance. The stopping distance can be calculated, but we do not need to do that. Okay, we just need to interpret our answer in part 1. So our answer in part 1, we know that it is 1.625 hours. Okay, that will actually mean that it is 1.625 hours for a van traveling at 60 kilometers per hour, because we're looking at v equals 60 for it to come to a stop. So this is a unique example whereby we're not looking exactly at the rate of change, but we're looking at the meaning of the gradient of the tangent if a graph were to be drawn. Understand what I'm saying? Okay. Any questions? No questions? Okay, if no questions, then we'll just end over here. Tomorrow we will go into connected rates of change. This one will work, okay? So